Welcome back to another edition of TEC Tube. I'm your host Ryan Hoger, and in this video we'll be going through A2L refrigerants. This is the first video out of two. In this first video we'll cover all the basics of the things you need to know, what the changes are, what the refrigerants are. We'll focus mostly on R54B, but it'll also apply to R32. And in the second video we'll go through the dissipation control system. Let's get started. So as you probably heard, we're phasing out all the current refrigerants that you're used to working with in the HVAC industry, like R410A and R134A. We're going to be using R454B and R32 as the main industry refrigerants. The old refrigerants have already begun the phase down cycle. We're calling it a phase down instead of a phase out. It began in 2022, as you can see on the chart. And we had another phase down at the beginning of 2024, and it continues on down until we get down to 15% of the refrigerant itself allowed to be manufactured, and then it just kind of levels off there. So it keeps taking those steps downward. Additionally, the equipment, the new installed equipment that uses these refrigerants is being phased out. So that begins on December 31st, 2024 is the last date manufacturers could build anything that uses 410A or 134A. And then January 1st, they got to start using the new stuff for sure. So they can build it the last day of 2024. Depending on what kind of system it is, will determine how long you can go and install it. So if it's a packaged system, like a rooftop unit or a PTAC unit or something like that, where there's no field piping involved, then you have 3 years after that date of manufacture to install it. So you have until the last day of 2027 to install it. If it's a split system, like I have right here, or a ductless mini split or something like that, or even a chiller that has split components, if it's got field piping required when you install it, then you have 1 year to get that installed. So the last day of 2025 is when you have to have that installed by. So the refrigerants that we're using, as I mentioned, are R54B and R32 in this industry. They have a significantly lower global warming potential than R410A, which is what those two are replacing. Everything per the EPA has to be below 700 global warming potential, which is why R410A is off the table, and most of the refrigerants that you're used to are off the table. So you got to be lower than that. There's a whole bunch of refrigerants the manufacturers were allowed to choose from the EPA, and most of them have settled in on these two refrigerants in particular. So both of these refrigerants are considered an A2L refrigerant. So historically, ASHRAE Standard 34 has had 6 boxes of refrigerant, if you will, and my chart here is showing you 8 boxes of refrigerant. So we had A's and B's. A's are low toxicity, B's are higher toxicity, right? So we're in the A category for our old stuff and our new stuff for HVAC. And then we had 1, 2, and 3, which are the levels of flammability. 1 meant it did not support any flame propagation. Like if you tried to light it, it wouldn't stay lit on its own. That was 1s. 2s would hold the flame, and then 3s were highly flammable, like propane, for example. These refrigerants are in a brand new category called A2L, which is slotted in between A1 and A2. Because they are technically flammable, you can get them ignited. It's possible to do that, so they can't be in the A1 bucket, but it's very difficult to ignite them. So I don't think anyone that develops these standards wanted to put them in the A2 category, which involves a whole bunch of extra codes that kick in on your project. So they literally created a new category called A2L, and that's where these are slotting in. Technically flammable, but very difficult to ignite. To kind of give you a scale of some of these things, the refrigerants we're talking about right now in the chart here are in yellow. So they are very close to the purple ones, which are the A1s. They're not all the way on the far end of the scale over here like propane, which is an A3. So yes, it's flammable, but it's barely flammable. Less flammable than hairspray, as you can see here on the chart. It is very difficult to ignite them. Here's a list over here of sources of ignition that will not ignite an A2L. And then there are things that will, like obviously our concern in the HVAC world is I take an acetylene torch to it. And in that case, I'll have enough heat of combustion to actually ignite this. So it is possible to ignite it, but it is very difficult to get it going at first. Just to give you a frame of reference, the auto industry switched over to A2L refrigerants in about 2013, 2014. So they're already using slightly flammable refrigerants. And by 2018, more than 50% of the cars sold in the United States already had A2Ls in them. So at this point, when you're watching this video, you're probably driving around in an A2L refrigerant car. So this is not a giant change for the world. It's just something new for the HVAC side of the equation. The cylinders that we're using for these new refrigerants are also different. So in this case, I'm showing you a recovery cylinder in yellow. It'll have a red band painted around it to indicate that it has an A2L refrigerant, and whereas your 410 cylinder did not say that. And then new jugs of refrigerant will also have a red band around them to indicate that it's an A2L refrigerant. All the refrigerants will be regular gray cylinders, and you'll have to read the tag to see what exact refrigerant's in there. The threading on all of these is going to be left-handed, so no more righty-tighty on there, on either one of these jugs, which obviously is annoying because then you can't say righty-tighty. It's left-hand threaded, so when you want to reuse your existing hoses for your gauges, you'll need one of these adapters on there that goes from right hand to left hand, so you can actually physically connect to it. So that's something that you'll need in terms of tool differences. There are other tools that will come into play. So any tool that you're going to be using on a refrigerant project has to be a sparkless tool. Most of the stuff you have is probably already that way, but it might not be. So what you'll need to do is look at the manufacturer that you have, of whatever equipment you have for recovery machines and for your gauges and whatever else that you're utilizing on the refrigerant. You'll need to look at the list from the manufacturer to make sure what you have is compatible with A2L stuff. So you just have to double check that stuff as part of the process. The other thing that's going to come into play is there might be some things that are different with your procedures in terms of installation and startup. Now, for you guys that were doing everything by the book on R410A, it'll be pretty minimal. You're not going to have to do much stuff different. It's just that things that used to be recommended for R410A, like purging with nitrogen and evacuating and those kind of things, those now become required things that you have to do. So at the outdoor unit, which in this case happens to be a heat pump, but an AC condensing unit would be the same discussion. There are some things that are the same, and there are some things that are a little bit different. Things that are the same condenser fans you're used to, same physical cabinets, same coils. Things that are different, the compressor is slightly different. The TXV in this case, because the heat pump is also a different TXV. Filter dryers that typically ship with the outdoor unit, they are defaulted to be set up for a press style fitting, a mechanical fitting, as opposed to in the past, they were already ready to be brazed. So now if you wanted to braze it, you'd have to add a coupling or swedge it. It's not that you're not allowed to braze with A2L, you are still allowed to do that, but the manufacturers are trying to encourage a flameless installation, hence they're making it easier for you to use a press fitting out of the gate. The stub outs for the outdoor unit are the same way. They're defaulted to be set up for a press style fitting to make it easier to do that. Once again, you can still braze it if you want to. You notice the cap on there was red. The service valve cap's also red in this case. That's just an extra indicator to the installer that they're working with an A2L piece of equipment in case they didn't happen to see the tag on here, or got the little flammability indicator on there, or if they didn't read the manual or something like that. On the indoor portion of this system, there are a few things that are different as well. On the stub outs for the piping connection, they're set up for a press style fitting just like we talked about. There's a tag on here that tells you you're going to be working with an R454B refrigerant in case you were not aware of that. There's the warning labels that are on there like you have on anything, but these are going into detail about the A2L aspects of it, so that's on there. And then if I take the front door off of this, factory installed in here is a refrigerant leak detection sensor. It's got a wiring harness on it that once I install the system, I will fish through the knockout on that front door, and this 4-pin wiring harness is going to connect to this dissipation control board. The purpose of this dissipation control board, which is a requirement by UL, you're required to have that sensor, you're required to have a control to manage that sensor for all systems. What that's going to do, it's going to intercept your thermostat signals, and if there happens to be a refrigerant leak in the coil for some reason, it'll A, shut off of your compressor, B, turn off any combustion appliances like a gas furnace that's attached to it, and then C, it'll turn the fan on to circulate air so that way the leak doesn't pool in one spot and it dissipates that refrigerant leak. The other thing that comes into play is that this is obviously a small system. If you have a larger system, maybe a 10-ton condensing unit, 20 tons, 30 tons, everything we talked about is still going to apply. This just happens to be a small one we worked on today. So nothing's different in that regard. Same controls and everything. If you have a package system, such as a rooftop unit, for example, it's a little bit different. You still have the same controls, you have all the same rules, but one, this is factory wired for you because it's all in one box, so they can do that. Obviously, with a split system, they can't factory wire it for you because everything's in different places. And then 2, none of the discussion about piping applies on a package system because it's already pre-piped for you. But the general concepts of what we mentioned still apply. Hopefully that gets you going on the A2L stuff. You definitely need to take a full-length class on this. We just kind of highlighted a few points, but there's a lot of things that you need to know that we didn't have time to touch on today. So take one of those classes so you're ready to go before you start your first installation. Additionally, we're going to have a follow-up video on the dissipation controls and how those work. So check that out when you get a chance. Thanks for joining us.